Hello guys, I hope you are doing great and I hope everything is going well. In this video, we are going to discuss simple machines. We will talk about the mechanical advantage and we will be also talking about the efficiency. So let us first start talking about simple machines, try to define them and try to describe or talk about different types of simple machines. So let's agree that a simple machine is a device that usually changes the direction or the strength of an applied force. So a simple machine usually changes direction or strength of an applied force. There are some main types of simple machines that are inclined plane, the lever, the screw, the pulley, and wheel and axle. These are some examples of simple machines. So the wheel and axle is like the bicycle paddle. So these are some types of simple machines, and they are main types of simple machines: the inclined plane, the lever, the screw, the wheel and axle, and the pulley. Okay, so we need to know, guys, that all machines help you do work by exerting smaller force. So when I use a machine, why do I use a machine? Because I want things to be easier for me. So I need to exert smaller force or moving objects over smaller distance. So why do I need machines? I need machines for two reasons that I need to know. First reason is that, let us write it here. So we need machines for two reasons. Reason one, to reduce force, or make the distance shorter distance. So these are the main reasons why I need to use a simple machine. However, we need to know that the machine will not change the amount of work you need to do. So the machine will not change the amount of work you need to do. Let me give you an example. So here we have the following inclined plane, which is a type of a simple machine. Here we have this simple machine, which is basically inclined plane. I'm just trying to drag this box to fit. Okay. So we usually use these types of machines in order to help us drag objects, for example, to the truck. So let's see how the work will not change. Assume that I'm going to lift this box and put it in the truck. So I'm going to lift it for a height of 0.6 meters, and I'm going to apply a force of 100 newtons. So I'm going to apply 100 newton in order to lift this box and put it in the truck. So the work is equal to force times distance, and this is the formula that you should study. So if I want to substitute the value of the force and the value of the distance, I'll get 100 multiplied by 0.6, and I will get 60 joules. So the work here is 60 joules. Now, if I want to use the inclined plane, as you can see, the distance increased, but the force that I will be using to pull the box upward will be less. So I will be using here a force of 60 newtons. First, I needed 100 newtons. Now the new work will be also its force times distance, and the force is equal 60 newtons multiplied by distance, which is equal to 1. I will get 60 joules. As you can see here, the work did not change. So as you can see here, the amount of work you need to do will not change. Okay, so the machine will increase the distance over which the force is applied. You see, the inclined plane increase the distance I need to move the object on. So in this way, the work needed to move this box did not change. So we say now, okay, so that's it for this part of the lesson. And now we are going to move to talk about something else, which is about the mechanical advantage and the efficiency. But before discussing that, we need to know different things and we need to know different definitions. So I need to know first that the force, the output force, is the force applied by the machine, which is also called the load. So the output force is the force applied by the machine. And also I can say that the work, the output work, is the work done by the machine. So be careful, there are work and force, output work and output force. Output work is the work done by the machine, and output force is the force done by the machine. Type. One way that machines help you do tasks is by changing the force you use. As you can see here, I have, for example, an input force or an effort which is equal to 100 newtons. But if I want to lift the box without the pulley, this is the simple machine I'm using here is the pulley, I need to exert more force. So one way why I need to use a machine is to reduce the force I'm using, okay? And when I'm apply less force, maybe I need more distance to do the same amount of work. So we need to know that the force is changing here. And when the force changes, the distance will also change. And we need to know that machines may also change the direction of the force. Now let's talk about the mechanical advantage. Mechanical advantage means the benefit from this machine, means how many times this machine can increase the input force, how many times it can multiply my force. So in order to calculate the mechanical advantage, I need to divide the output force over the input force. So in this case, the output force is 200 Newton. So the machine or the device I'm using, which is the pulley, is applying 200 Newton of force. And personally, we are applying, or this guy is applying 100 Newton force, which is the input I'm applying into. So in order to calculate the mechanical advantage, I divide the output over the input or the load over the effort. So I divide 200 divided by 100 and I will get the answer of 2. And the mechanical advantage is greater than 1, which is something I need. When the mechanical advantage is more than 1, يعني the machine is efficient. So I can use the machine. The machine is doing great job. It has an advantage. But if the machine is giving me 100 Newton, let's say, so the mechanical advantage will be 100 over 100. Why do I need a machine that will keep my force as it is? I will not benefit. I can simply pull the object or push it without using the machine. That's why the mechanical advantage should always be greater than 1, so that I can say the machine I'm using or the device I'm using is beneficial for me. Okay, so as I mentioned as well, the input force is called the effort and the output force is called the load. You need to memorize these things as well and to know that they also have different names. The input force, we call it the effort, which is I am exerting on the object, while the output force or the load is the force applied by the machine on the object. Now, since we talked about the force, the input force and output force, we need to know that there's also something called the input work and the output work. The output work is the work done by the machine. And let me tell you, for example, that the distance between the object and the distance that this object will be crossing is about 5 meters. Okay, is about 5 meters. So let us calculate the output work of this machine. The output work of this machine will be 200 newtons multiplied by 5 meters equals to 1000 joules. And if I want to look at the input work, let's say that I am applying an effort of 100 newton, which is the force, and we know that force times distance will give me the value of the work. Okay, so force times distance will give me the value of the work. So the input work is 100 newtons multiplied by 12 meters is equal to 1200 joules, which is greater than the output force, that the output work. So the input work is always greater than the output work, greater than the output work. Okay, you need to know this information very well. The input work is always greater than the output work. So guys, the efficiency is the ratio of the output work to input work. So I divide output work over the input work and I multiply it by 100. Why? Because I want the answer in percent. So to find here the efficiency, I divide 1000 over 1200 and I will get 0.833. If I want to multiply it by 100, I will get the answer of 83.3%. So the efficiency of this pulley is 83.3%. Let me tell you that there is no machine that is efficiently 100% because of friction. Friction causes some energy to be transformed into thermal energy. And this thermal energy is wasted because it cannot be used to do work. So what friction does is that it increases the effort. Because there's friction, let me explain it well from this photo. If you want, for example, to push this object through this inclined plane, there's a friction because the box is touching the rough surface of the wood, for example, if I'm using a wood to push the box. So the friction will tell me, or will help me, or will ask me to exert more effort in order to push it upward because I want to resist friction. And if you remember previously, we mentioned that the friction, when you rub the two objects against each other, or when you're moving, the thermal energy is increasing. Which is wasted because it cannot be used to do work. Okay. So basically, that's all about the mechanical advantage and the efficiency. I wanted to remember that the output force is different than the output work. And output force is the force applied by the machine on the object, and the output work is the work applied by the machine on an object. And as you can see here, the output force is always greater than the input force, but the output work is always less than the input work. Keep this in your mind, guys. If you still didn't get this lesson, please write me down in the comments what do you need me to explain further to know this lesson better. And please also, if you have any question about any other concepts, please write me down in the comment box, and I will see you in new videos later on. Have a great time, guys.